So when we treat this compound 1 with B2H6 and NaOH, then what is the major product? This is our problem, and basically we know by seeing this reagent it is an hydroxylation reaction. So basically here two things are involved. One is stereochemistry and another is regio selectivity. Whether the hydroxylation would occur in this site or this site, and whether the hydroxylation will occur from the above phase or the below phase, that will we will learn in this problem. So basically this compound has open book like structure, right? So by seeing the stereochemistry we know that the H are like upwards. So basically this phase is kind of blocked due to the presence of this group. So the upper one phase in which the hydrogens are directed are more available for the electrophile BH3 to attack. So when BH3 attacks, there are two orientation which give rise to two transition state with transient positive and negative charges. Okay, so we take one of the orientation of BH3. Okay, so in this case we see that the boron, here is the boron, okay, and here is the hydrogen. It attacks from this side, okay, from this way. So in this way, here is the hydrogens there. So what will form now? It will form the positive charge in here, and here are the BH3 minus. So it's kind of transition state. It is not. It has a very transient stability and cannot be like trapped easily. Okay. So in this way, this transition state is formed. Okay, this TS is formed, and we know this TS. The oxygen is very close to this positive charge. Kind of this TS is destabilized. Okay, so this TS is kind of destabilized. But if we see the other orientation in which the boron attacks from the other way, that is in this way, okay, in this way, then what will happen? That transiently the positive charge will form here, and here's the boron, and here are the hydrogens. Okay, so in this way the hydrogens will be there, the hydrogens will be there. So positive charge is kind of away from the electronegative group, that is the oxygen. So kind of this TS is kind of stabilized compared to the TS, this TS. So when we treat this, so this TS will be the majorly formed. Okay, so when we treat this with NaOH and H2O2, hydroxylation takes place, and it will ultimately form the OH containing compound in this way. So what will be the ultimate stereochemistry of the complex? Like in this way, the hydrogens will be upward, these hydrogens will be upward. So this will be the major product. Okay, so the major product will have a stereochemistry with hydroxyl group upwards, and which are pointed in the same direction as that of the hydrogens. So if you find this problem useful for your GATE-NET or IIT JAM preparation, so please do like the video and subscribe, and your support is very much important to us, which keep us motivated. Thanks a lot.